I'd like to welcome everyone. Very thankful for all of our listeners. With that being said, I'd like to introduce myself. My name is Nikolai, commonly referred to as Nico DMT within the FetchAI community. I'm joined today by our CTO, Edward Fitzgerald, and we'll be showcasing the Agentverse. For those of you who missed it, the Agentverse is a live virtual hub where the purpose of it is to help everyone engage and understand with agent-based technology. On the one hand, it serves the purpose of, well, through the graphical interface, you can easily create and deploy agents. And on the other hand, if you are a dev and you'd like to explore, the platform gives you the ability to easily audit all of the code. So with that being said, Ed, can you hear us? Your mic is mute.
Certainly can, yeah. Put my camera on as well. Hello, everyone. Excellent.
Hello. Alrighty then. Well, I've given us a short introduction. Ladies and gentlemen, this is our CTO, Edward Fitzgerald. And with that being said, I'd love to hand over the mic and let you take the lead and showcase.
Fantastic. Thanks, Nico. Cool. So, as Nico has very eloquently said, we're going to do a bit of a walkthrough of the Agentverse. There's quite a lot of pieces there. So, specifically in this session, I'll be going through the managed agent part, which I think is probably quite interesting to everyone here. I think we'll almost certainly have subsequent sessions where we focus on other parts of the actual Agentverse that we have here. Although we're going to be working with managed agents, and that means code, I won't assume any kind of prior knowledge from that perspective. All of the code that we support in the Agentverse at the moment is Python-based, and that's primarily because it's sort of coupled with our microagents library that I guess you guys are aware of. But we're going to go through those, and we'll look through some examples, and I'll kind of give you a bit of a sort of a tour through all of those kind of features. And then obviously we want to leave a little bit of time at the end for questions and answers, sort of, and all the other sort of bits and pieces that we have there. So given that, I think let's probably share my screen and we can start getting into the sort of meat of the presentation. That would work through. Cool. So hopefully you can see my screen. Yeah, I think I can see it in this Discord window. Excellent. Cool. So this is the Agentverse. This is sort of our sort of explorer of agents, if you will. And this initial page that you land at is all about finding what agents are available at the moment and sort of what protocols that they support. We'll kind of get into a little bit of that later on. But as I said, I wanted to focus on today on the managed agents part. So in order to access that, you need to sort of sign in here and sign in with Google here. And then you'll see across the top here, we have our four sort of main areas effectively of the Agentverse. So discovery, obviously about finding agents to kind of communicate with. We have our managed agents. We have our mailroom. This is about making mailboxes for your micro agents. This is particularly useful if your agent is going to be offline or in an environment where you don't want to actively, serve the web server half of the agent. And then we have some utility panes for usage and stuff like that. So great, managed agents. This is kind of what I want to focus on in this sort of talk. And so I won't assume any knowledge about micro agents, but the technology we're using and what we're hosting here is the micro agent technology. So we will go through some of the fundamental parts of that on this call now. So yes, we'll go from there. So what is an agent effectively? What is a managed agent? Maybe we'll start from there. And the kind of story here is sort of Fetch's mission is to be able to give agents to everyone, to get everyone to use agents and to start automating their life. Our sort of the Fetch vision is about the sort of world where, we will do less and less, human to machine, communication, and much more. You'll have systems of autonomous execution happening on your behalf. So you will give a high-level task, and then the sort of your agents will then operate on that sort of target and will work towards that goal. Cool. So an agent in terms of a micro agent is effectively a piece of code that has a kind of identity. So it has a kind of private and public key kind of paired with it, and it can send and receive messages between other agents. That's sort of the minimalist construct for an agent. So what we are doing here in this managed agents tab is taking care of that kind of deployment side of things. And, we worry about managing the kind of private key of the agent, etc. And you as a developer only have to worry about kind of supplying the kind of code to get your agent to do something on your behalf. And we'll sort of walk through that. So if we let's just create a kind of blank agent here using this interface. I assume everyone's had a look through this, but effectively, when you select your agent, you're greeted with sort of two kind of input panels here. You've got your kind of code that's here, and you've got your logs over here. And this is sort of similar to kind of like a Python REPL in some sense. And so we can say hello showcase here, and then we can run that. And it's the most uninteresting agent possible, but you see the point of me running the execution in the background for you on your behalf. So hopefully people are getting the idea that this is pretty powerful kind of construct. Cool. So let's carry on from there. So this is sort of uninteresting, I guess, as an agent. So we'll go into the kind of four main constructs of the micro agent framework that we have. And they are sort of intervals, message handlers, storage, and protocols. And protocols are a way of organizing sort of the message handlers and the intervals together. We copy this agent address here, then we can kind of delete it. We need it for the bit here. So we added this section in here, which gives you kind of categories of examples that you can kind of use to get started with in the kind of Agentverse for your agents. So we'll start with the first one here, which is our sort of interval agent, my first agent here. There's a lot of text here, mostly comments to kind of guide you through it. So I will kind of go through some pieces here. So as the documentation says, there's a couple of things that you should know about this environment that's sort of different than if you were to do this with micro agents, for example. And the first one of that is that the sort of agent instance that we have here, and that is referenced here, is automatically injected into the kind of runtime that you're editing in here. And that's the sort of managed part. That's the managed agent of the system. And people who are familiar with the micro agent library will be aware of this sort of decorator style syntax that you annotate your functions with to give them sort of semantic meaning. So these sort of lines that we have here is this sort of managed agent that we have here that, as I said, is sort of injected into the sort of global scope here. We have an on interval and we have a kind of period, and then this runs this function here. And so this is sort of giving your program some level of agency in the fact that it can wake up and execute start an initiation of a kind of protocol or something like that. It can start some action on a kind of period. This is very common, obviously, common paradigm. In this example, we sort of showcase that this sort of context object, which gets passed into this function, has all the sort of things that you can interact with from a kind of micro agent's perspective. And in this very simple example here, we use the logger object and we print out a kind of message. And in this example as well, we show that the address of your agent is also inside the kind of context object you have here. So if we run this here, you can see we get like kind of log message here. And obviously, because this is running on an interval that we've specified here, it's going to keep printing kind of forever. And to show that you guys that this is obviously real, we can change this as well. To be unimaginative. Cool. So you can kind of see that this is alive and this is working on your kind of behalf. Right. So that's good, and that's the first sort of building block of a kind of micro agent. This is sort of used in this sort of managed environment. Let's get one level more complicated. And this is about sort of messaging between agents, which is the sort of bread and butter of agents. They need to be able to communicate with each other. So I've loaded up this example that I appreciate I whiz through a little bit here, but we've got Alice and Bob have been created as these two agents here. This is your classic kind of ping pong messaging example that we're going to run through here. So let's have a look at the code for Alice. So a little bit more code, but there's a few bits and pieces here. So the first thing is that we define this sort of model or this message structure. This is actually a very similar paradigm to, I don't know if people have used it, but sort of Fast API, these are the sort of web frameworks that help supply the kind of message formatting for data payloads. And so we have a very simple request here, and it has a single attribute assigned in message, and it's a string. So we have this nice typing. And the way this object works, it uses a library under the hood called Pydantic, and it means that it'll do the sort of data validation when you try and serialize and deserialize its things. But cool, what do we have here? Well, we have in terms of our agent program, we have two sort of decorated calls here. So we have this on message, which is really this new thing that we're showing in this example, and that gets called every time your agent receives a message of this type request here. And again, in this example, we don't do much with it, other than we sort of say, "Thank you very much. I received this message from this particular sender," which is going to be an agent address. And then to sort of make this example sort of more complete, we are going to, on an interval, we are going to send this request message to another agent. In this case, this is Bob's address that we set up here. And there's a few things that are going on under the hood here, which is kind of important, which is how does the system translate this agent address into something you can contact on the internet? And what's happening there is we have what we call our almanac contract, which is sort of what's being shown in the discovery pane. And it's providing that kind of lookup between agent addresses and the sort of endpoint that you need to use to send your message to another agent. Cool. So this is what we have here. So at the moment, the sort of summary of the code that we have here is we have a very simple request message as a single field in. We've got some logic for our agent Alice to basically just log out every time it receives a message. And we've got this on interval periodic action that Alice is going to take to send a message to Bob. So let's have a look at what is Bob doing with this example. Cool. So Bob has a similar message structure here, as you would expect, and it has a single. In this case, with Bob, it has a single message handler here, and this is the sort of pong side of the ping pong example here. So first of all, Bob will print out a message to say, "Thank you very much, I got that message," and then it will send back a response to whoever sent it that message. We have a special condition here. Effectively, if we know it is from Alice, then we can say "Hello there, Alice" in our message, rather than "Hello there, friend." So we can run these two agents. Let's go back here to Alice and Bob, and we can see the kind of output that's going on here periodically. And you can see here that we sent a message to Bob, and then we received a message back here, "Hello there, Alice." And in a similar way, if we go back to Bob here, scroll down here, you can see that we have Bob's message. So these messages are being serialized, they're being sent through the system, we're doing the lookup on the almanac contract, and then we're coming back to the hosted agent to run the response, and you're sort of ping-ponging between each other, which is pretty cool. Now, this is a very simple example. You can obviously step up the level of complexity with this, but it's sort of showing you the kind of fundamentals that we have here. Yeah.
While Ed is cleaning up a little bit, I just like to give you a bit of a short recap. So what you're seeing over here is the managed agents section of the Agentverse. In order to access this, all you need to do is open up agentverse.ai, sign in ideally with your emails, click on managed agents, and you'll be able to follow along and recreate everything. The agents you're seeing right now are micro agents as part of the recently released micro agent framework. And what you've just seen are two examples. One is a simple agent interaction, and the other one is agent communication. And as Edward mentioned just a moment ago, communication between agents is really the bread and butter of agent-based systems. And as we continue to incrementally improve the Agentverse. The examples you're going to see are going to grow in complexity, but also grow in utility. In that, once agents are able to interact and communicate, that really opens the door for advanced and sophisticated use cases, including use cases that can easily be implemented in either any industry or a business or a DeFi context. And
Correct.
then.
Yeah, correct. Yeah, thank you for that nice summary, Nico. Yeah, that's correct. These are
No
all
problem.
these are all very basic examples here. And again, the sort of target here is to sort of give you a showcase of the fundamentals of the technology, and then we'll build up, as we say, the kind of complexity of the examples as we're going along. And at the moment, we're kind of releasing these examples on about every week kind of basis, and I guess people have seen the updates for there, and this is going to grow over time, from there. But very much we want to start and bring everyone along in a kind of progression here on kind of complexity and sort of build up. But hopefully this is starting to sort of ignite some imaginations in some people about what's possible. Cool. So we've covered the 2 out of the 4 sort of core pieces of microagent technology that we want to kind of talk about. So that's our intervals and our message handling. These are sort of bread and butter, as Nico sort of said nicely. The next 2 we're going to look at is sort of storage and protocols. So if we go through our getting started bit here and then go through our agent storage, let's have a look at the code for this here. Again, this is a very simple agent, just so that everyone can read and understand and sort of follow along here. But effectively what we have is we're now accessing this storage object inside the context that kind of pulls in here. Now, if you were to run this example in sort of from microagents running locally, this would store all your data to like a JSON file locally. So it's a sort of simple key value storage. This is what this interface is. So it has a sort of get, sets, deletes, and sort of clear semantic. And what we're doing here is we're basically looking for kind of, do we have a value stored here with the key count? And if not, then we set it to 0, and then we sort of print this out, and then we set the kind of count to whatever our count is plus 1. And so this then, because it's called on an interval, is going to be called every sort of 3 seconds here. So I can run this here, and then sort of every 3 seconds, we're going to get an extra log message that sort of appears down here with this incrementing count that happens here. So storage is really important, obviously, because if you've got all these different callbacks between for different kind of messages, and you have a more complicated kind of protocol, you need a place in order to store session data. If you get a order request or request, for a reservation, you need to be able to record that somewhere so that if someone asks to reserve the same thing again, you can decline that kind of request. And in the sort of managed environments, we're obviously running all of these things for you. And so we kind of provide a very simplistic set to start off with. If you are running this locally, just using the kind of microagents Python library, this is just Python code. So it's very easy, and there's examples in microagents to hook this up with a more traditional kind of ORM or database driver, and you can connect to whatever you like, your Mongos or Postgres or Cassandra, or whatever kind of database you want to kind of hook this up to. Cool. So this is the kind of storage bit. And the final example that we're going to go through in this sort of showcase is the one that we released today. This is sort of like a very simplistic restaurant sort of protocol set of agents that's sort of here. This is kind of combining all of these sort of things together in what we call a kind of protocol. So let's have a look at the code here and kind of go from here. So now the first thing, well, there's a few things you'll sort of see from here. We've got a similar kind of structure that we've seen in other examples. This is a very sort of simplistic table booking interactional protocol where we have a kind of request here for a table number, and then we get a response with a sort of success, true or false, and the kind of table number that you kind of requested. But what is new is we got this protocol. And I guess in some sense, it's worth thinking about protocols as like sort of divisions or groupings of these sort of message and interval handlers that are for a particular kind of use case. And the idea is that instead of assigning your message handlers to a particular agent, or the agent at the kind of top level, you put them in this sort of protocol container. It follows exactly the same kind of syntax. And then what you can do is you can just include that protocol in your agent. And that's important because if you want your agent to support a whole library of different kind of protocols, then you need a way of being able to split these out in a nice sort of separable fashion. And it also makes a difference for when you register what protocols that you, on the sort of almanac side and the sort of discovery side, it makes a difference there so that other people can find you. So it's a sort of logical separation or group of these sort of protocol messages and interval handlers. Cool. So let's look through what this code does. So we have this sort of booking protocol, and it's relatively straightforward. So we have a booking request, and you'll see this new bit here, which is replies. And this is important when we build up the representation of the actual protocol. And we say what messages can be emitted from other messages, and you can imagine you can build up quite a nice sort of graph of all of these sort of interactions about this. So in this case, it's relatively simple. It's a request response, and obviously, again, as Nico has said, we're keeping all of these examples very simple and easy so that we can kind of demo them in an easy way. And this is the kind of Python set operation, set syntax, set literal syntax here. So this is a set of things. So it would be possible to have multiple versions of these different parts. Otherwise, this looks exactly the same as the other ones. But the logic here is a little bit more complicated. So this is where we're booking the table. Or sort of, simulating booking the table. We look in our storage and we check if there is a value inside our storage map here for this particular kind of table number. If there is, then obviously success is false in this particular case. If there's not, we just got our else bit here, then great, this is successful. We write the kind of table number into the storage with the sender's address inside here, and we print a little message out here for good measure. And then at the end, sort of come what may, we then send out the booking table response along with our success code that we set here, along with the table number that the person or the agent kind of requested. So you can sort of bring this down into a very simple reservation system. So we come onto this a little bit. There is this other part here, which we've done, which is on an interval. We kind of clear the storage, and that's useful for this example because so that it runs in a loop effectively. Cool. So that's kind of like a very, very simplistic restaurant protocol, right? And we can kind of go to the client. What does the client side look like this? Great. So again, it has the same set of structures here. This defines the data types that it's going to kind of talk. On an interval, it's going to look to see if it already has an existing booking. If it doesn't have an existing booking, again, using a similar approach that we used in the other example, then we're going to effectively randomly decide a sort of table number, and then we're going to request on our restaurant a sort of booking request for that kind of table number. And so that's great, but obviously then we need to handle what happens when that agent comes back with a response, and we have that here. And if it's successful, great, we print out a message to say that was successful. And we also set our booking value here, and that effectively stops us attempting to find another table at this particular kind of restaurant. And then in order to have this set of agents run in a cycle, we have this other interval that we've sort of tagged on the end here, which clears all the previous bookings. So if we then run this one, let's run the restaurant first. It doesn't actually really matter the order. And then we come to the kind of clients here. What you can see here is attempting to book, table 99 successfully books, and then you can see it's clearing its previous bookings and it's trying again. And then in a similar side here, when we go to the restaurant, you'll see 99 was booked, 81 was booked, clearing the booking and go from there. Cool. I can stop these now here. And I guess the other thing to mention is, obviously there's an element of kind of like compute and stuff that's going on here, and you can use this usage tab here to see sort of how many seconds and process messages and other bits and pieces that you have that are specifically for these sort of hosting of these sort of managed agents that are kind of here. You can see how you can go there. And if you need more like allocation or what have you, then we'd love to hear from you, and we can definitely sort that out for you guys as well. Cool. I guess that's been a bit of a demo at 100 miles an hour. That's mostly what I wanted to talk through for this particular session, and I'd love to switch to kind of questions if anybody has any.
There are a couple of questions actually that we've received both throughout the actual demo as well as earlier today and while we were leading up to the demo itself. Interestingly enough, they are all a bit of a higher level questions, not necessarily relating to the code or micro agents, more so relating to the broader concept of the Agentverse.
Yep.
Okay. Alrighty then.
Well,
Should I start?
Well, maybe we just ask the audience if they've got any specific ones on the kind of detail here, and then I'm very happy to talk through the kind of high level ones as well, Nico.
Lovely. Yes. Crypto.ai has a question. Sir, I will elevate you to become a speaker. This works exactly like Twitter Spaces does. So once you're invited to speak, please accept and feel free to ask any questions.
Yes, can you hear me?
Yep,
we can hear you. Welcome.
You have a question according to this context and data storage. Can you tell more about this? Those agents sharing this data storage, do we have some kind of constraints of this data? How much data we can store there? And when this context is created and so on, so on. Thank you.
Yes, really great question. Yeah, so the storage effectively, to answer your first question, which is about what is the restrictions on that, it's anything that is effectively JSON serializable. So all the examples I showed were relatively boring, I think, with strings and ints or whatever. But anything that you in Python you can serialize to JSON will get stored there. You will actually get an exception if you try and do anything more exotic. That's sort of there. There is a storage limit that's in the system that is sort of applied. It's not actually here in the usage at the moment, but is sort of applied in the background. You will see an update relatively shortly where this box will basically say how much storage you have available. It is sort of sandbox storage between just your agent effectively, so you can't share any data between agents using it. But yeah, that's the sort of main one. Did that answer your main question? I feel there was another question there as well, like how does it work? Maybe is that correct?
Actually, I wanted to understand where the data is stored also. So is it stored in Ledger? It's like kind of part of transaction or not?
No. It's not in there. It's actually part of this sort of hosting platform. So if you want to know, it lives in a kind of Cassandra database. So it gets the real sticky details like that. but yes, you obviously can interact with the ledger and send transactions to put stuff on storage. But we expect this kind of write rate and the read rate from the storage to be very high, for agents. So we wouldn't want to put it directly on the ledger, unless you make that kind of conscious decision to do so.
Okay, thank you. And quick question. So we already have possibility to use another agents, which registered not via Agentverse. For example, correct. I have agent and in mainnet and so on. Can I use it from here already?
Yeah, so there are some restrictions, like as you can imagine, like running a hosted agent service for sort of arbitrary Python code poses some interesting security considerations. I guess you can put it like that. But so it's not a complete sort of Python available. I guess the biggest thing that you will see that is there's no way in the current setup for you to install your own packages like requests and other bits and pieces like that, or TensorFlow or other sort of libraries that you might need for kind of more exotic use cases. That is sort of in the plan and the showcase to sort of come up in the later versions of the Agentverse, but we're sort of building in that complexity as we go along. But that would be the idea, or the ultimate idea, effectively.
Okay, thank you.
Cool, great questions.
Thank you, Crypto.ai. Feel free to stick around if you'd like to. In the meantime, there's been a couple of more questions that arose. I think the first one is related to the examples and the incremental complexity aspect of it. The current examples are somewhat, they're foundational, but they're also somewhat boring. So the question is, can we get examples that are also useful? So that was, I think that what that means, can we get examples where people can simply use the graphical interface to launch an agent that already gives them some value in, I would assume, a Web3 context.
Yeah, that's exactly where we're going. I mean, like this is sort of part of the problem with this sort of platform, is that we want to do two things with it. We want to give people stuff that's useful, but also expose them to the technology. So the approach that we've taken is to start with sort of simple cases, bring people on for that kind of journey, and then every week we're going to show more and more sort of layer on this the sort of complexity. So yes, stay tuned, buckle up. Basically, it's around the corner.
The second question we have is, can we run these agents made through the Agentverse on other networks?
At the moment, on the managed agents, no, there's a sort of set of restrictions there. If you were to take that code and run it locally with the microagents library, absolutely. Absolutely, and it's relatively straightforward to do. So again, this is sort of part of the roadmap of what we sort of make available, and that's going to be we're going to incrementally add all of these sort of bits and pieces to it. But yes, fundamentally, there's nothing stopping the base level technology doing that. That's relatively straightforward. This managed product is a little bit more restricted at the moment for sort of obvious security reasons, and we will incrementally open that up.
The third question that's arisen is this a developer tool? So that I would assume that by this they mean the Agentverse. Is the Agentverse a developer tool? Is it a tool for normies? In other words, non-technical people.
So at the moment, it's definitely a sort of tool for more developer-oriented sort of people. I would say that Python is probably your easiest jumping in language for sort of getting into that side of things. It is part of our vision to make this more available to sort of a wider audience, and we will release updates in that direction as we sort of go along. But primarily at the moment today, very developer-focused.
Final question is, does this create utility for the FET token? So I would assume that... I'm not going to assume, actually. Feel free to answer that.
Yeah, absolutely. So we haven't gone into this, and we will do another showcase on this separately. This whole Discover tab, this Almanac contract that I've made references, we'll do a proper deep dive into that. But effectively, registration on that Almanac is on chain, and therefore will create demand for Fetch token. So the Fetch network, in that sense, will become the kind of central coordinating layer for this sort of ecosystem of agents, effectively. Well, thank you very much for your time, everyone. Lovely to have you along. And I guess Nico will give more details as we go along for more of these sort of showcases. And we'll get into more nitty-gritty topics, I'm sure.
It's a pleasure to host the first showcase. And as you've mentioned, I'm looking forward to more showcases. And in the future, we'd also, I believe that there's merit in asking the community what they'd want to see. So in the future, if you have any ideas for specific showcases, or you believe that you'd like a detailed explanation on a technical concept, for example, the micro agent framework, feel free to request that. And
I think we should definitely do one, Nico, with the kind of comparison to this version with how you'd run this sort of locally. I think would be kind of interesting as well.
Yeah, I think people would find that interesting as well. I definitely agree. I also think that we've got also a couple of other ideas that we're planning on. So in general, the theme of, or rather we'd like to turn these Discord showcases into a bit of a pattern for the project, and turn them into the de facto place where both non-developers and developers can stay informed and genuinely dive into granular level aspects. They're very practical as well. So yeah, I think that's a great note on which to conclude, and I'm thankful for everyone's time. And thank you, Ed, as well.
Thanks, everyone. It's been a pleasure chatting to you.
Thank you, gentlemen, and have a nice day.
Cheers. Bye-bye.